So today we're going to have our last notes on Unit 6, which is going to be the triangle proportionality theorem, as well as mainly just parallel lines and proportional parts. So this is just telling us when we have parallel lines that we have some special relationships between these similar triangles. So if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So that just means that these different segments that are created, so like BD and DA and BE and EC, we're creating proportional parts there. So we're going to say that if DE, oops, let me fix this. So if DE is parallel to AC, then we can say that BD over DA is going to be proportional to BE over EC. So we're just taking those different parts, those different segments that we've created now with that parallel line, and we're just making a proportion from those. So our converse is just that we're switching these. So we're saying that if BD over DA is equal to BE over EC, then that means that DE is going to be parallel to AC. So for our examples, we want to find the value of x. So number 1, we have these parallel lines, which means that these parts are going to be proportional. So we're going to have 14 over 12, and we're going to set that equal to x over 15. So I started with the portion that's in between the parallel lines. So I started with that on the left side, so I have to start with that on the right side as well, with x here. So again, I'm just going to cross multiply. So I end up with 12x equals 210. And I divide both sides by 12, which is going to give me x equals 17.5. Again, it is okay to have a decimal for these. So same thing for number 2. We would just set up a proportion, and then we are going to solve it for x. So we have our proportional parts. So for this one, we can say x over 18 equals 56 over 21. All right, so again, I'm going to cross multiply. So I have 21x equals 1008. So I divide both sides by 21, and I get that x equals 48. So nothing really different from what we've already done with these proportions. Now we just have this one triangle where we have these proportional parts, and we just have to figure out what's going to go in our proportion. So we're going to try number 3. So I'm going to have you guys try number 3, and then I will go over it. All right, so on number 3, when we set up our proportion, we should have x over 36. And then we're going to set that equal to 10 so 10 over 45. So this whole side is 55, which means that this little part right here is 10. So that is how I would get my answer there. So now I just cross multiply. So I get 45x equals 360. Divide both sides by 45. And I get that x equals 8. All right, so we would do the same thing with number 4. So it gave us that whole side length. So you would just subtract 6 to get that other part, which would be 21. And you would set up your proportions, solve for x. All right, so we could have on like number 5, where we do have some algebra. So again, same thing. We have our proportional parts. So we can say 30 over x plus 7, and we can set that equal to 25 over 15. So for this one, I'm actually going to simplify this fraction before I cross multiply, just to make my numbers a little bit smaller. You don't have to do it this way, and you will get the same answer, but sometimes it's just easier to work with smaller numbers. So I know that both of these can be divided by 5, so I'm going to have 5 over 3. So now I can cross multiply. So I'm going to have 5 times x plus 7, and I'm going to set that equal to 90 for 30 times 3. So I want to distribute this 5, so I get 5x plus 35 equals 90. So now I want to subtract 35 from both sides. So I get 5x equals 55. Divide both sides by 5, so I get that x equals 11. All right, so we're going to do the same thing on number 6. So I want y'all to try number 6. All right, so on number 6, same thing. We are going to set up our proportions. So we use our numbers that are on the same side. So we have 6 over 21, and then we set that equal to x minus 1 over 3x plus 1. So again, I'm going to simplify this because I know that 6 and 21, both of those can be divided by 3. So I get 2 over 7. So now I'm going to cross multiply. So when I write it out, I have 2 times 3x plus 1, and I set that equal to 7 times x minus 1. So I'm going to distribute, and I have something that I have to distribute on both sides now. So I have 2 times 3x, so I have 6x plus 2 equals 7x minus 7. So I'm going to subtract 6x from both sides. So I get I get 2 equals x minus 7. I add 7 to both sides, so I get that x equals 9. All right, so then we can also have some examples where we're determining if these are parallel or not. So what we want to do is we just want to set up a proportion, and we want to figure out if they are going to if these sides are proportional to each other. So if we had 11 over 15.4, and then we also have 10 over 14. So what we can do is we can plug them both into Desmos, see if we get the same decimal. I mean, that's really the easiest way that you can figure out if they're proportional. If they're the same decimal, then it's going to be proportional. If they're different, then it's not. So if we plug this one in, then yes, they would be proportional. Number 8, we can do the same thing. So we could say 15 over 4. And then we can have 18 over 5. So just looking at these off the top of my head, I already know that they're not going to be proportional, but again, you can plug them in and see for yourself. But these are not going to be proportional. We shouldn't really see any examples like this, but it is good to know. All right, so then we have proportional parts and parallel lines. So if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So if we know that all of these parallel lines, we know that they're all parallel. So if we know that AB is parallel to CD, which is parallel to EF, then we can say that AC over CE is going to be proportional to BD over DF. So again, we're just making those proportional parts, and we're pretty much doing the same thing we were just doing, except now we just have those 2 transversals that are cut with those parallel lines. So again, we just set up our proportions. So number 10, we can solve for x. We can say 45 over 18 equals 52 over x. So I cross multiply here, I get 45x equals 936. So divide both sides by 45, and I get that x equals 20.8. All right, so we're going to skip number 11 for now. We're going to try number 14 on here. So number 14, I'm going to have you guys try it, and then I'm going to go over it. All right, so on number 14, we should end up getting that x equals 5. So what I'm going to do is I'm going to write out my proportion. I have 24 over 18, and I'm actually going to simplify that before I solve it. So I end up getting 4 over 3. So if I divide them both by 6, I get 4 over 3. And that's going to be it's going to be equal to 3x plus 1 over 12. So now when I cross multiply, these are going to be a lot simpler. So we're going to have 3 times 3x plus 1 equals 4 times 12, which is going to give me 48. So when I distribute this, I have 9x plus 3 equals 48. I subtract 3 from both sides. I get 9x equals 45. If I divide both sides by 5, I get x equals 5. All right, so these examples that we skipped over, we were going to go over in class, but we are doing the same thing with our proportions. We just have to figure out how to set them up, and when we have these parallel lines, it's just creating those proportional parts.